Hello, this video is titled Topic Recap on Giant Covalent Structures. In particular, we are looking at diamond and silicon dioxide. I'm just going to go through with you a recap really on what simple covalent molecules are and what giant covalent structures are. Now don't worry if you haven't covered simple covalent molecules yet. It might be that you're studying those at a later point, but you can learn giant covalent structures first and you can learn simple covalent structures first. It doesn't matter either one. But just what a simple covalent structure looks like. So if these Venn diagrams look familiar, it probably means that you know how to bond simple covalent molecules, okay, which is great. It's on the GCSE spec, that's absolutely fine. In terms of this actual video, we're looking at giant covalent structures. What is a giant covalent structure? And it's these pictures. So for these pictures here, you wouldn't be expected to show bonding like that between them. Okay, so most molecules or covalently bonded molecules are just individual molecules like so. Okay, so like fluorine, this is water. I haven't drawn the crosses or dots in, but they are the shapes that you'll probably recognise. Now, what will happen is, in giant covalent structures, rather than just having a couple of atoms, we actually have hundreds and hundreds and thousands all covalently bonded, and when atoms do that, they turn into giant covalent structures. And at GCSE there is a set of giant covalent structures you must know about. Diamond and silicon dioxide are probably the first two that you will start to learn about. Now this is diamond, okay? Diamond's picture looks like so. Most of the diagrams you see will look like so, okay? And actually each of those dots in carbon is a carbon, in diamond is a carbon atom. Okay, so if you didn't know this already, diamond is essentially just made out of carbon. That's all it is. Carbon is a fantastic element. It can take on so many different forms, from something really, really beautiful like diamond, all the way through to something like the graphite in your pencil. Okay, it's a wonderful element, has lots of properties, depending on the form that the form of its structure. Okay, in this structure, we essentially have lots of carbon atoms bonded to other carbon atoms. Okay, and if you look, most of the atoms, okay, like the one that I pointed to here, each carbon atom in this structure is bonded to 4 other carbon atoms. Now carbon has 4 electrons in its outer shell. Okay, and every single one of those electrons will be involved in bonding to another carbon atom. Okay, and it creates a covalent bond. And by bonding like that, it gives carbon these 3 properties. Diamond is very, very hard. Okay, the hardest natural substance on Earth. So even though these individual atoms are carbon, formed together in a structure like so creates diamond. So the bonding in diamond makes it very, very hard. This PowerPoint is actually slightly outdated. It says it's the hardest natural substance. It's definitely the hardest natural substance. It's not the hardest substance on Earth, like you previously might have seen on other PowerPoints. Now, diamond has a very high melting and a very high boiling point. The reason being, every single one of these black lines is a covalent bond. Now, covalent bonds need energy to break them. And if we've got hundreds and hundreds of these bonds, each of those bonds needs lots of energy. Add up all of that energy, it needs a lot. Okay, so therefore it makes diamond have a very high melting and a very high boiling point, and that's why diamond is also very hard, because each of these bonds has to be broken. So therefore it makes diamond very, very hard with high melting and high boiling points. Now diamond cannot conduct electricity, which you would hope to see, because if you think of diamond as in lots of jewellery, particularly rings and things like that, earrings, you wouldn't want your jewellery to be able to conduct electricity. The metal part will, but the actual jewel part, the diamond, if that's what's in the ring or the earrings, the actual diamond part doesn't conduct electricity. And the reason being, there are no free electrons in this structure. okay, because the 4 carbon electrons, every atom here has 4 electrons, okay, and every electron is involved in bonding. If there's no freely moving electrons, you cannot have an electrical current. That's diamond. My other example is silicon dioxide. Okay, now silicon dioxide is a silicon atom bonded, okay, to 4 other oxygen atoms. So in diamond, each of these dots was a carbon atom. Now we're not looking at just carbon atoms, we're actually looking at silicon and oxygen atoms, okay? So every silicon bonds 4 times to another oxygen atom. Now in terms of properties, it has exactly the same properties as diamond. Silicon dioxide is quite hard, okay, it has a very high melting and a high boiling point, and it does not conduct electricity. However, it is weaker than diamond and has a lower melting and a lower boiling point than diamond, okay. So again, if you look here, every red dot has got 2 yellow dots, which is silicon. Every silicon has got 4 bonds from it to bond to an oxygen, okay. So lots of bonds, not as many bonds in the giant covalent structure of silicon as to compared to diamond, which is why it's not as hard and why it has a low melting and a low boiling point. What I'm now going to show you is some exam questions, very common exam questions here, where you are asked to relate the property, a given property of a giant covalent structure, and then explain why it has that property. And these can be worth anything from 2 marks up to 4, 5, 6 marks. I've got 2 4 markers here. One is about silicon dioxide, the other is about diamond. So the first question says, silicon dioxide is used as a lining for furnaces. Furnaces can be used to melt iron. So straight away, I would be thinking, well, if we're melting a metal, whatever is in that furnace must be able to withstand a really, really high temperature. And it says, explain why silicon dioxide is a suitable material for lining furnaces. So you need to think back about what we've just spoken about on those previous slides, plus notes that you've also made yourself. Think back, why would silicon dioxide be a suitable material to be in that hot furnace? You would then have to explain why. So you need to think of a property of silicon dioxide and then explain that property. The second one, you can see here, it's a describe and explain question. It says describe the structure of diamond and explain, and it's given you the property it wants you to talk about. This one hasn't. It's suggested, it's talking about melting things, so it's suggesting a property. This question actually gives you the property. Why does diamond have a high melting point? And describe its structure. So again, think back to the previous slides where I've spoken about diamond. What does it look like? What's being bonded within its structure? What type of bond? Then think back, why does it have a high melting point? Okay, what makes it have a high melting point? So have a go at those questions or replay the video and then come back to the questions. If you once I finish talking, if you leave the video to play, you will see my answers come up. These have been pulled from a GCSE paper. So on the next slide, you will see a GCSE style mark scheme.